Yeah. So is the screen visible? Yeah. All right. So let's look at the first question. So let me write the question, then I will ask what you have got. So this is about finding remainder. So we obviously know the remainder factor theorem, but the purpose of this question is to take it, maybe try to take it one step further and see if the same method of, putting values and finding remainders could be applied rather than doing the long division process. Okay, where you find the quotient also, which is good, but we don't need it now. We don't need it in this question. So that is what we are trying. Okay, let's see. So find the remainder when x to the power 100 plus x to the power 99 plus x to the power 98 is divided. So intentionally, so there's a quadratic here, but it has a factorization. So that that's what you have to put to use. So yeah, so maybe whoever has done, you can start saying or tried. I mean, not done. I don't mean that. Just if you have tried anything, just begin. Don't wait for the other person for to say or something. So no attempts. You did the other ones. Okay, let's see. Ishana, what about you? Because I want to know, because then only I can understand like what is the thinking, where you're getting stuck. I tell the solution, but I should try to know what you have done and where you're getting stuck. Okay, I understand. Yeah. So you would try to maybe write this, take pieces of x minus 1 times x minus something like that, maybe. Yeah. Okay, no problem. Okay, what if I tell you, what if I simplify the question and tell you find this? Then how would you do this? You would apply the remainder theorem, right? But what is the equation from where the remainder theorem comes? So that is easy. We can do that. See, the equation where the remainder theorem comes is that basic equation of a polynomial, quotient, divisor and remainder, right? That always stands. Is that right? So if you're dividing this by x minus 1 times x minus 2 times, so you'll get some quotient. So just writing it hypothetically, in the sense we do not know the answer, but we're still just right. That's what we always do in algebra, right? We pretend that we know, so we call it x and then eventually find it. It is something like that. Here is like the quotient is the thing and the remainder is the thing. These two are like the variables, maybe. We are only interested in the last one. So do you agree? So do both of you agree that this kind of thing can always be written? Yes or no? Is that okay, right? I mean, so I'm not asking for a rigorous proof, but we have discussed that. And you would have read, and this is this thing that when you take a polynomial, you divide it by something, you get a quotient and you get a remainder, and this is what it means, right? Right. Can you tell me something about the remainder? Like, okay, you cannot find the remainder, fine. But can you tell me something about the remainder? That is the first thing. Yeah, any one of you? Can you tell me something about the remainder? Could you tell me what can its degree be? At least whatever you can tell about the remainder. what should its degree be? Or, a degree, or what can its largest degree possibly be? Okay, Aparna, what do you think? Yes, right? It could be 1, it could also be 0. It could be 0, but it cannot be more than 1, right? So why am I saying it could be 0? It could obviously be 0. I mean, in the sense that in general, right? So if I give you this polynomial, in this case, the remainder would be 0 because it's a multiple. So it could be 0. It could be also constant. You could produce an example easily, but it cannot be more than that, right? In the sense, I mean, that is the part of the statement. That's a part of the statement, right? And yeah, you could. So, I mean, obviously, I mean, you could write this equation so that this degree is more than 2. You could do that, right? Just like when you take a number like 17 and you divide it by 4, we we actually put that in the condition that you don't want the remainder to be more than 4. We write it like this, but you could obviously write it like this also. I mean, then it won't be called a remainder in the standard sense, but sometimes this is useful, we have seen, right? Either ways, point is that you can find an Rx which degree is less than 1, and that is the good thing. Can you use it? Use this. That is the thing. Try to use this new knowledge, because I mean, now you know that Rx is not more than a linear polynomial, right? So any ideas how you would use it? Okay. So no problem. So you've not done this kind of questions earlier. That's why this is going to be, after you do this, you will find this is a standard play. Always this kind of questions are there, and we build on this. Because there is certain thing to it, right? You're going to be able to find the remainder without finding the quotient. That is the heart of this model arithmetic and even polynomials. I mean, that's the point of studying this theory. Otherwise, if you had to find the quotient, then you can always go and do it, right? You could take long pages and you can find the remainder, right? But well, what I'm trying to say is that because it is linear, why not, I'm just using the standard thing, why not write it like this? Why not just write it, the fact that it is linear? Or now can you use it? You can use this. Like, see, I mean, in the remainder factor theorem, that's why it's important to understand the remainder factor theorem on a conceptual level, not just as a theorem, but as a consequence of some substitutions we make, right? If you're just dividing by x minus 1, then you knew that it is a constant. And that's why it was just the instinct to put x equal to 1. Right? Substituting x equal to 1 does give you b. It is not the remainder factor theorem, or I mean, it's not because the theorem says so, but because you can see it. Right? You put x equal to 1, it's the instinct to put x equal to 1 because this will become 0, and then you get the b. Here, what should you do? What substitutions should we make? That is the question. After you've used this, what substitutions should we make? is the idea of substitution making sense? Like substitute, how it is the idea of substitution that really tells you that, you know, the B is f of 1, is P of 1. If you had to just, if it was just, you know, dividing by x minus 1, it is the substitution idea. Here, what is the natural thing to substitute? What should I put in place of x? Simply, the word substitution is nothing, it's just what should I put in place of x? You want to substitute, you're saying 3. Yeah, so let's see what you substitute. So if you substitute 3, then what will you get? What did you say after that? No, but you have the q of 2, and that is the biggest problem, or 3, q of 3. Okay. Now it should tell you what you want to substitute. Yeah, I mean, it's good that you make an attempt. That's very important. Otherwise, there is no learning. So substituting 3 in this case is not good. See, really, you want to substitute things so that this really is out of the question. That is the real thing, right? No, why will it? No, if you use 0, it will be q of 0. Q of 0 is not 0. You don't know q of 0. Okay, right, okay. Aparna, what do you think? Do you, so those things did not work so far. Do you have any new ideas? Any new things that you would like to substitute? No. Okay, so let me say it more explicitly. If I'm trying to take it slowly, I want you guys to somehow say the answer in the end. Okay, just maybe hence, what makes this 0? What surely makes it 0? Is that expression that I squared? What surely makes it 0? Yes, I mean, that is what everything is about, right? X1 and x equal to 2. So you substitute x equal to 1 and you substitute x equal to 2. Do it. Okay. So you substitute x equal to 1 and you substitute x equal to 2. You'll get two equations in A and B, which you can easily solve. I mean, these numbers are big, but they are not a problem. I mean, you don't have to find 2 to the power 99. You just write that in the answer wherever it appears. Is it clear now? You have to finish it on your own after this. Right? So it's 2 to the power 100. Up and now, is it making sense now that when you put that, then that really makes it work, right? You get a plus b, and then similarly you get 2a plus b. Sorry, so this will be 1. Right? And then similarly for 2. So less than a minute is left. I'll launch the meeting again because of some issue. This meeting is going to end. Okay, I launch it again, but you can just easily solve these equations and find a and b. That's it, easily. You don't have to really find 2 to the power 100. Okay, so we meet on the other side, just in a second.